Okay, so welcome back to this video on the G-inhibitory pathway. So in this video what we're going to do is we're going to look at some pharmaceutical or pharmacological, because not all of them will be pharmaceuticals, but pharmacological agents which interact with this pathway basically. Okay, so we're going to start off with the very start, which is the receptors basically, and pharmacology is all about receptors. That's really what it is. It's the study of receptors, and because most drugs act at receptors. So we're going to look at a bunch of drugs which interact with a bunch of receptors which are coupled to GI or GO heterotrimeric G proteins basically. Okay, so a very, very famous one, firstly. We're going to look at morphine. Okay, so morphine basically is an agonist for a G protein coupled receptor that is coupled to the GI protein or the GO protein. So morphine is an example of an agonist for the G protein coupled receptor, which is okay, so which G protein coupled receptor is it? It's the mu-opioid receptor. So this is mu-opioid receptor. Okay, right. So that means that when morphine binds to the mu-opioid receptor, when morphine binds to the mu-opioid receptor, it activates it and increases its catalytic activity and increases its activation of the GI pathway, basically. So morphine is an agonist for the mu-opioid receptor. So what other receptors are coupled to GI protein? Well, another example is the 5-HT1B receptor. So this is a receptor that's for which the endogenous ligand is 5-HT or 5-hydroxytryptamine, which is another name for serotonin. Okay, and we're also going to look at the receptor 5-HT1D because they're both coupled to GI/O heterotrimeric G proteins, and they're both obviously therefore G protein coupled receptors. Right, so the endogenous agonist for these two is serotonin, or 5-HT basically, 5-hydroxytryptamine. But there is a non-endogenous agonist, which is sumatriptan. Okay, so tryptamine, and basically an example of a non-endogenous agonist or an exogenous agonist is the drug sumatriptan. Okay, so sumatriptan basically binds to these two receptors which are coupled to the GI pathway and is going to activate them, increasing their activation of the GI pathway. Okay, so again, these two receptors, these 5-HT1B receptor and the 5-HT1D receptor, they are both G protein coupled receptors. Okay, so let's have a look at another example of a G protein coupled receptor. In this case, it's going to be the cannabinoid receptor 1. Cannabinoid receptor 1. Okay, so the cannabinoid receptor type 1, basically. Okay, so this has by its name, we know where it came from. It's basically activated by one of the components of cannabis, tetrahydrocannabinol. But basically, there is a drug which is an antagonist for this receptor. So it binds to it and does not activate it, but stops the endogenous or exogenous agonist, in the case of cannabis, from binding to it. And this drug is rimonabant. So rimonabant is an antagonist, a competitive antagonist. It will bind to the site where agonists such as tetrahydrocannabinol or whatever the endogenous agonist is for cannabinoid receptors, and it will stop them from being able to bind. So rimonabant is a competitive antagonist for this receptor. And again, the cannabinoid receptor 1 is a G protein coupled receptor which is coupled to GI/O heterotrimeric G proteins. Okay, so now we'll go to the dopamine receptors. So there are 3 dopamine receptors which are all coupled to the GI pathway basically, and they are D2, D3 and D4. They are all coupled to the GI heterotrimeric G protein or the GO heterotrimeric G protein. So they all activate the G-inhibitory pathway. Okay, right. So the drug haloperidol is an antagonist for all of these. So I'll draw it inhibiting them all. So this is haloperidol. Okay, right. A famous treatment for schizophrenia. Quite a horrible drug, though. Haloperidol. Okay, so haloperidol, what it does is it binds to these receptors and stops the activation of them it stops dopamine from being able to bind to them, and it itself does not stimulate an increase in the catalytic activity of the receptor. So again, it's a competitive antagonist. Competitive antagonist. Okay, right. And now what we'll look at is some drugs which are agonists for these dopamine receptors